ना को बैरी नहीं बेगाना सगल संग हम को बनाई नो वन इज माई एनिमी एंड नो वन इज ए स्ट्रेंजर आई गेट along with everyone. Unit 4, Part 3, Dipole Moment and Fajan Rules by Amrik Singh, PGT Chemistry. Dipole moment. Dipole moment can be defined as the product of magnitude of charge and the distance between the centers of positive and negative charges as shown below. We have two charges and the distance between them charge is q and distance between the centers is r. Then dipole moment will be equal to magnitude of charge, that is q, and distance of separation, that is r. Q R. Mu is equal to dipole moment is represented by mu. Mu is equal to Q into R. Dipole moment is usually expressed in Debye unit, D, capital D. 1D is equal to 3.34 into 10 raised to power minus 30 coulomb meter, where C is coulomb and M is meter. Dipole moment is a vector quantity and its direction is from positive to negative charge. In case of polyatomic molecule, the dipole moment is the vector sum of the dipole moment of various bonds. Dipole moment of some molecules are explained below. First one is a dipole moment of NH3 and NF3. We have NH3 molecule, shape of NH3 is pyramidal with lone pair, and dipoles direction are shown by the arrow. Hydrogen is partially positive and nitrogen is partially negative. The three dipoles are hydrogen to nitrogen and one dipole is nitrogen to lone pair. And in this way we will get the whole resultant up in the upper side, and all the dipole moment are adding up and the resultant is more. All the dipole moment are adding up as shown. Now in case of NF3, uh, we can see the arrow. Fluorine is partial negative and nitrogen is partial positive here, because fluorine is more electronegative than nitrogen, and direction of dipole moment is n to f, n to f, n to f. And other case n to in other for the lone pair, that there is a direction from nitrogen to lone pair. Now the resultant will come downward. These dipole moments are downward and dipole of lone pair is upward. Therefore, there is not addition. Something is subtracting here. That is the dipole moment of the lone pair. Therefore, the dipole moment of molecule NF3 will be lesser than NS3. In NS3, all the dipole are adding. That's why it has higher dipole moment. All the dipole moment are not adding up, as shown in the diagram. Dipole moment of water is not zero. This shows that it is all dipole are not cancelling out. Now first dipole is hydrogen to oxygen, hydrogen to oxygen, oxygen to lone pair, oxygen to lone pair, and resultant will come upward. And therefore the dipole moment of water is not zero. That and it is proved that it is not a linear molecule. All the dipole are adding up. Now dipole moment of CO2 is zero. It proves that it has a linear shape. CO, here is O, and the direction from carbon to nitrogen, dipole direction of positive to negative, oxygen is negative, carbon is positive, again carbon to oxygen, and these two dipole cancel one another, equal and opposite. Therefore resultant dipole moment is zero. In this case equal dipole moment are cancelling up. Now dipole moment of BF3 is 0. We have the shape of BF3, triangular planar shape. All the dipole moment are coming from boron to fluorine, and resultant here for these two bonds, resultant is here. For these two bonds resultant is here, and net dipole moment will be zero in this case also. Here equal dipole are cancelling up, mu is zero. Type of molecule there is table, and the molecule are given and their dipole moment are also given with their shape. Okay, dipole moment give the idea about the shape also. You can read this table. Now next is significance or application of dipole moment. Distinction between polar and non-polar molecules. Non-polar molecules such as nitrogen, oxygen and hydrogen have zero dipole moment, whereas polar molecules have non-zero dipole moment. For example, dipole moment of water HFHCl H2S are given in this way. One values are given, but and these have the dipole moment, therefore these are the polar molecule. Degree of polarity in a molecule. Greater the value of dipole moment, greater is the degree of polarity. This relationship specially hold true for diatomic molecule. HF is polar, more polar than HCl, because dipole moment of HF is 1.78 and for HCl is 1.07. Now, shapes of the molecule. Water and carbon dioxide have dipole moment 1.85 d and 0 respectively. The water has angular shape and carbon dioxide has linear shape. Because dipole moment is 0, dipole moment should be cancelled. They can cancel only for linear shape. Ionic character of in a molecule. The percentage ionic character is the ratio of observed dipole moment to dipole moment for complete ionic character multiplied by 100. Percentage ionic character is equal to mu observed divided by mu ionic multiplied by 100. Distinction between ortho, meta and para isomers. It helps to distinguish between ortho, meta and para isomers. Dipole moment of para molecule is 0. Dipole moment of ortho is greater than the meta isomer. Symmetrical molecules have zero dipole moment. For example, BF3, CH4, etc. Zero dipole moment because these molecules are symmetry and number of lone pair is zero in central atom. Fajan rules. Just as all the covalent bond have same ionic character, covalent bond ionic character, same ionic bond also have some partial covalent character. The partial covalent character of ionic bonds was discussed by Fajan in terms of following rule. Smaller the size of cation and the larger the size of an ion, the greater the covalent character of the ionic bond. The greater the charge on the cation, the greater the covalent character of ionic bond. For cation of the same size and charge, the one with the typical transition metal electronic configuration, that is N-1, Dn, Ns0, is more polarizing than one with the noble gas configuration Ns2, Np6, typical of alkali and alkaline earth metals. Homework, some questions are given. These are the NCERT exercise asked many times in the examination. मेरे मन परदेसी वे प्यारे आओ करे, oh my dear beloved stranger mind, please come home into God's feet and meditate on God. ਹੇ ਥਾਂ ਥਾਂ ਤੇ ਭਟਕ ਰਹੇ ਮਨ, ਹੇ ਪਿਆਰੇ ਮਨ, ਕਦੇ ਤਾਂ ਆਪਣੇ ਘਰ ਪ੍ਰਭੂ ਚਰਨਾਂ ਵਿੱਚ ਆ ਕੇ ਜੁੜ. Thank you for watching this video.